coefficient when we looked at the table. So we determined the correlation coefficient on the previous data set, and we said, and I have it right here, I wrote it, I copied it for you. So we determined this, and then we went straight to the table, and we said we have n equals 8 entries. Let's see if this is okay. According to the standard, it's okay, because it's a number greater than 0.707, whatever that was. The same thing here, we want to make sure that we are within certain limits, and we can say, yeah, the least squares regression line is okay for this model. So we want to compute what is called the coefficient of determination. That is very easy because it's simply r squared. So we already have the correlation coefficient. All we have to do is square it, and that will give us the correlation coefficient. Now, correlation coefficient is denoted by, it's given by everything, by TI. So this is the correlation coefficient. I'm sorry, coefficient of determination. And is nothing else but the correlation coefficient squared. If you remember, the correlation coefficient is a number between -1 and 1. When we square any number between -1 and 1, obviously r squared will be between 0 and 1. When we square anything, it's positive. So the determination coefficient is a number between 0 and 1, and the correlation coefficient a number between -1 and 1. Question: why do I need this? Why is the coefficient of determination important? It measures the proportion of total variation in the response variable that is explained by the least squares regression line. So r squared, for those of you who don't have this document, measures the proportion of total deviation or variation in the response variable that is explained by the least squares regression line, or the line of best fit, we call it, by the least squares regression line. I'm going to write it like abbreviated from now on. So the least squares regression line. It tells us, so the higher R, the better the model is. The error is explained. So the smaller the deviation, so if the deviation or the errors, if you want, are small, close to the regression line, higher R will be. Better the model will represent the data set. Okay, so r squared equals 1 means that the least squares regression line explains 100%. That's really impossible, really, to happen, but very close to almost all of the variation in the response variable. And if r is 0, then we will say the line has no explanation. The line is not going to help us at all. Okay, so for the previous example that we worked on, for the club head and the distance, we're asked to find the percentage of total variation in the response variable. In other words, we are asked to find r squared, the coefficient of determination. And I have 0.93869584 that needs to be squared, which is r squared. And when I do that, where's my calculator? Right here. Let's see what we get. Let's also put in the data in the graphing calculator because I need it for later. So let's put it in and calculate it, and it will give us the answer. So tell me if you fall behind so I can stop and do this again. Stat and edit. press enter. As you see, I parted with all my data, almost. So we had the following entries in the previous data set, and I already put them sorted. 99, 100 twice, 101 after that, 102, 103, and 105 twice. Make sure you have 8 entries. And now let's go across and put the y values in the correct order for corresponding to the x values. 99 corresponds to 258. 100 corresponds to 257 and also to 263. And then 101 to 266, 102 to 264, next one to 274, next one to 277, and 275. Of course, I make sure that I put the numbers correctly. I think I did. Yes. So let's go back to stats. You can log out of there like second and quit. Go to stats. And now we want to calculate. And we will definitely get the linear regression, the least squares. Again, go back to number 4, down to number 4, linear regression. Press enter. Make sure you have list L1, make sure you have list L2. And go to store. I would like not to have to type in this function, the line, the linear, the least squares regression line in y equals myself. I want the calculator to do it. So let's press on variables right here, VARS. Go across to y variables. Select function, press enter, and then y1, press enter. So now, after we complete the calculations and get whatever we need, which are correlation coefficient, a correlation of determination, and the linear regression line, the least squares regression line, automatically the calculator will store it in y1. So let's press enter, go to calculate and press enter. And that's what we have. And I already wrote it on the handout, but I can write it again. And you see you have R, which was 0.938, and so on and so forth. I think I copied this from StatCrunch. There must be some error, a minor error. It's very possible. And R square is 0.8811498758. And you could ask how many digits? I would say 4 would be enough. 4 decimal digits will be enough. So this is good enough. And we also have the regression line. Careful how you put it in. It's already up here. So A in the calculator is the slope and B in the calculator is the y-intercept. So I'm going to write it again. It's y hat, the predicted, which is 3.166. I'm going to stop at 4 digits. X and minus 55.7966. Okay. Our next step I would like us to I need to change my marker. Tip. Okay, for the next step, I would like us to graph this line. And with the graphing calculator, very easy. We go to y equals, right? Here it is. Here's the function already in there. I don't know why the calculator puts the plus and then the minus. It's not correct. I hope it's going to graph it. We'll see in a moment, but it's not correct. I don't know, maybe your calculator doesn't do that. If your calculator doesn't have that feature of putting the line in, put it in now. Which line in y equals? Put in 3.1661x minus 557.7966. Put it in y1 if your calculator doesn't have that feature of adding it on or saving it directly. Okay. So now when we look at zoom, click on zoom for a second, And there is a feature, again, not all calculators have this, called item number 9 here on the menu, called Zoom Stats. So I'm going to do that. This was the scatter plot that we had for L1. Let me see, make sure, because I may not have L1 in there. I don't have L1 and L2. So I'm going to do it again. L1 and L2. So here's what I have at this point. So you go to second and stat plot, make sure that you turn on plot 1 or any other, 2 or 3, but 1. Make sure that you select the first one, which is the scatter plot. Make sure that your X list is L1. Make sure your Y list is L2. You choose any marker you like. It can be a square, a cross, or a star, or a dot. I like the stars. So you can change the color. I never did that, to tell the truth, but let's see, it's red now. And you can graph with the zoom stat. Nice. So the calculator gives me the scatter plot, and it will graph also the linear regression line, the line of best fit. Which line is this? Okay. Careful, because you do not see 0 here. This is not actually 0. It just zooms in where the data set is and the line through it, the linear regression line. Okay. Now, what I would like to do next is find the residuals for each entry. We have 8 entries. It's not a big deal. Right before that, I would like to draw something that explains where the error or the residuals are again, and where the total variation is, or total deviation is. So keep this in mind. I'm going to graph this. I'm not going to graph the X and Y intercepts, because these numbers are at 100, 99, 100, 101, 102, 103, 105. So this is X 100, 99, 100, 101, 102, 103, and 105. So this is what I'm going to copy. Okay. Because I need to copy it to explain what I'm trying to do here. Okay. So I'm going to make a break in the graph, also on the y-axis and on the x-axis. This is not 0. I put it 0, but it's a break in the graph. I'm going to write 99, 100, 101, 102, 103, 104, and 105. This is still the x variable, the explanatory variable, but here I have residuals. Not yet. Actually, I don't want to do the residuals just yet. I want to graph. The y bar. Y bar. I copied all the calculations from last time. I want to copy the point x bar, y bar first. X bar, y bar, which means the mean of x and the mean of y. This is the ordered pair. I will get to the residuals, but I want to show something else before I plot the residuals. So x is 101.875, and y bar is 266.75. I don't need anything else from the previous data, so I know that the y values are between, so the range of y, and we have them where they're on the previous handout. I hope you have them. I have them here too. So between, we entered them, 258 and 275. So this is the range of y. So 258, 260, 262, 264, 266, 268, 270, 272, 274, 270, what was 270 up till 277, yes, 276, 278. And I'm going to delete this. This is not the residuals yet. The graph of the residuals is coming up. Okay, so I'm plotting the data. I'm also plotting this point, which is at 101, somewhere here. This is X bar, and 266. 266. I'm going to draw a horizontal line that represents Y bar 266. Of course, it's 0.75. I don't have enough room there, but you understand it's not exactly 266. And here is the point that is X bar comma Y bar, this point. The linear regression line, the line of best fit, has to pass through this point. Mandatory. So we already graphed it. We have it in the calculator. So I know how it looks. I'm going to plot the points first, and then I'm going to draw the line approximately, because it will take a long time for me to graph it very exact. Okay, so one point is 99 to 58. 99 to 58 is right here. 100 to 57. Oh, yeah. Oops. 257, right here, yeah. The next one is 263. 263, also for 100. Next one, for 101 to 66. Close here. For 102 to 64. 264. For 103, 274. And two more, 277 and 275. 277, somewhere here, and 275 for 105. Yep. Okay. So the regression line, I may have some, let me see, at 100, what was it, 160, 157, this was 266, 157, 163, 163, 257. Okay. So the line has to pass through this point, so it's a must. And I just want to show, so this is the linear regression line. And I just want to show the explained and the unexplained. I'm going to pick point 103. So the coordinates for this point are 103, comma, what was it, 274. So this distance between the point and the corresponding, and the Y bar, this distance is the total deviation. This piece is the residual between this point and the predicted value. This is the error or residual or unexplained. Unexplained by the linear regression line. And this piece is the explained error. Explained. By what? By the linear regression line. Explained deviation. By the linear regression line. So on page 2, at the top, I have all these and how we calculate them. So the total deviation is y minus, so the entry for the actual entry for the y value for each point minus y bar from this point till this point. This is the total. What is the explained? Explained, let me move this out of the way. The explained is the y hat minus y bar. This is the explained. Y hat minus y bar. And what is the residual? Or the error? Or the unexplained? Is this distance between y, the unexplained between y and y hat. This piece. Y minus y hat. Okay, finally my next step, get your calculators again, and let's calculate all the errors. And now I'm going to create another table for you, so we can continue. So we can put everything in the table. Okay. So here we have x. Here we have y. Here we have the predicted through the linear regression line. And here we have the residuals. Y minus y hat. So this will be this list minus this list. So I will enter again all our data. So we have it in front of us. Let me take these out of the way. So we have it already in the calculator, but I need to show it on paper as well. 100 appears twice, and then 101, and then 102, 103, and 105 twice. The y values are correspondingly 258. You have them in the calculator if you already entered them with me. 266, 264, 274, 277, and 275. Okay, now let's get our calculators. Go back to lists, edit, stats, and edit. Go across to list L3, highlight the top of the list where it says L3. And let's do this. Remember, we have our function in y1. So all I want is call y1, click on variables, go across to y variables, and call y1,